Next property of Fourier transform, modulation theorem. So first for complex Fourier transform. If f bar of p is a complex Fourier transform of f of x, then the complex Fourier transform of f of x cos ax is 1 by 2 f bar of p plus a plus f bar of p minus a. Given f bar of p is a complex Fourier transform of f of x, from the definition Fourier transform of f of x, which is equal to f bar of p, which is equal to 1 by root 2 pi integral minus infinite to plus infinite e power I px f of x dx. That is equation number 1. Now we need to find the Fourier transform of f of x cos ax. So capital F of x cos ax, which is equal to replacing f of x by f of x cos ax in equation number 1, 1 by root 2 pi integral minus infinite to plus infinite e power I px f of x cos ax dx. We know that cos ax, which is equal to, in terms of e, right, e power iax plus e power minus iax by 2. Because e power iax we know cos ax plus sin ax, De Moivre's theorem, right, plus e power minus iax, which is equal to cos ax minus I sin ax. So adding these two, e power iax plus e power minus iax cos ax plus sin plus I sin ax plus e power minus iax cos ax minus I sin ax plus I sin ax minus I sin ax get cancelled, so you will get 2 times e power 2 times cos ax. So by 2 and 2 cancel, you will get cos ax, right? So using this idea, so that is equal to 1 by root 2 pi integral minus infinite to plus infinite e power iax f of x into e power iax plus e power minus iax by 2 into dx, right? So that is equal to, so 1 by 2 is a constant, take it outside, so 1 by 2 into 1 by root of 2 pi integral minus infinite to plus infinite e power I px e power iax plus e power minus iax f of x dx. So 1 by root 2 pi into 1 by 2 integral minus infinite to plus infinite e power I px into e power iax. So we are multiplying with e power I px into the 2 times e power iax and e power minus iax, right? So first e power iax f of x dx plus, so splitting the integral also, plus 1 by root 2 pi 1 by 2 integral minus infinite to plus infinite e power I px into e power minus iax f of x dx. So that is equal to 1 by root 2 pi into 1 by 2 integral minus infinite to plus infinite e power, grouping the power of e power I is common, x is common, take it outside, so you will get I p plus a into x f of x dx. Similarly in the second term, plus 1 by root 2 pi into 1 by 2 integral minus infinite to plus infinite, grouping e powers, so I is common, x is common, so take it outside, e power I p minus a into x f of x dx, right? That is equal to 1 by 2. So grouping 1 by 2 is common, take it outside, so 1 by root 2 pi integral minus infinite to plus infinite e power I p plus a x f of x dx plus 1 by root 2 pi integral minus infinite to plus infinite e power I p minus a x into f of x dx, right? Which is equal to, so Fourier transform of f of x cos ax, which is equal to 1 by 2. So first term is nothing but f bar of p plus a, because we know f bar of p is nothing but e power I px. So in equation number 1, right? So in equation number 1, replace p by p plus a, you will get f bar of p plus a. Similarly in the second term, replace p by p minus a in equation number 1, f bar of p minus a, right, by using 1, right? So which is to be proved. Thanks.